Hey guys, this is Nifty Culture. I'm NiftyMike. Today I'm doing a video on smart contracts. It's going to be a pretty basic introduction video, but I think it might help a lot of people with all these new projects that are coming online. The things I'll probably be covering today is how to find the contract on OpenSea, some basic information about what you're seeing on EtherScan when you click through to see the contract, what the read and write section of the contract is on EtherScan, and then we'll do a little bit of deep dive into the code. The stuff that I'll be talking about is like, how can you tell if it's a ERC 721 contract or 1155 contract, minting, max supply, editing the base URI, which is something some of these contracts can do, which would let the founders basically change the metadata after the fact. And then we'll just kind of look for any other kind of weird stuff that might be going on in these contracts. So I figure in the last couple of days, we've had a bunch of new projects launch. There's the Bored Ape Kennel Club, this Wicked Craniums project, there's Alien Boy, and then there's this My Pickle project. So I haven't looked at any of these contracts before, so you're kind of seeing me see it for the first time, but I thought that would be kind of an interesting way to see it. So you can kind of basically look over my shoulder to kind of see my process as I'm looking at these contracts to try to see what's going on inside of them, if there's anything weird or anything like that. So let me go ahead and share my screen and get started. So I mentioned the best place to get to these contracts, just the fastest, easiest way, which is usually pretty safe. Although if you really want to be double extra careful, you can try to go to the project's website. But OpenSea, especially once they've put the little blue check on these projects, it's usually a pretty safe way to find the contracts. So I'm going to just start. The order that I'm going to go in is probably most volume to least volume, let's say. So let's start out with Bored Ape Kennel Club. So if you want to find a contract, pull up the project. The best thing to do is just find one of the tokens that's being sold in the collection and click into it, and then go down to the details, and that's where you'll always see the contract address of that token. And if you right click on that, open a new tab, that'll bring up the EtherScan page for that contract. So once you're in here, you'll see, of course, all the transactions that have occurred on the contract recently. And then the important tab is this contract tab right here. Click on that guy. And sometimes, but not very likely, but there'll be a few projects where for whatever reason, they won't have attached the source code to the contract in EtherScan. That's a bit of a red flag to me. I've seen it on maybe a handful, like 1 in 10 major projects will kind of skip this step, but you always really want to make the contract visible to your potential customers or potential audience, because they might find some bug and report it to you, for one thing, but also that transparency is really necessary for people to easily be able to tell what's going on with your contract. And there's some important stuff that we'll go over that you can see if you can access the code. Even if somebody doesn't publish the contract source code, you can still decompile the bytecode that's here. It's just a lot more of a pain to read it. And whereas I can skim a smart contract in like 10 minutes at most and get a good understanding of what it's doing, if it's the bytecode, then it's like, you're never really sure if you're reading it right. And it takes, one method might take 10 or 20 minutes to try to get a handle on what it's doing. Okay, so once you're in here, you'll notice like this is kind of an interesting thing for people who are just trying to look up metadata or something. Like one of the ways, or like try to see how many tokens are still left to be minted on a contract. So there's two important tabs here, or there's 3 tabs with the code tab, but there's 2 other tabs here that are very interesting and very useful. There's the read contract page and then the write contract page. And what this basically is saying is, on the read contract page, these are all functions that you can call and it'll just give you a value back from the contract. On the write contract page, these are all functions that if you called them, they would actually change the state of the contract in some way. So like if you were minting a token from this contract, like if you mint it from the project's page, it'll be calling one or more of these functions in order to mint that token. The read contract, you can just invoke it whenever you want to, especially if you want to see like, if I want to see, like I was saying, the total number of tokens that have been minted, most contracts will have like a total supply function. So we can see on Bored Ape Kennel Club, as of 9:22 p.m. Sunday evening, Central Time, they've minted 8,600 of the 10,000 total dogs that are in the collection. So if you're wondering, like, you want kind of a real-time number of how many tokens are left to be minted, you can come in here. The tricky thing to keep in mind is that the contract state only gets updated when each block is written. And so if while a block is being created, there's multiple transactions for the same contract inside of that block, then it won't update after each one of those transactions. It'll only update when that block is added to the chain. So for instance, if it's like 9,995 and you're trying to see if the last 5 have been minted, and you might want to try to get the very last one or something, then you run the risk of all 5 of those mint transactions going into one block, and then it'll just go from 9,995 to 10,000 in one single block, and then you'll miss that whatever thing you were trying to do. So this is a super useful function here. Another really useful function is whenever they have like a token URI function. So if you put in the number of a token in the collection and query the contract, it will actually give you back the current metadata address of their current metadata URI for that particular token. So you can see I put in 6150, and then it spat out this URL that I can browse to, and then hosted at that URL is the metadata for this particular token. And you'll see, like, you can even kind of tell with this mystery here that probably this is just a placeholder image, and this is actually what OpenSea is going to use when they're showing the image. So if we go look at that IPFS file, then it's just going to be, you know, the mystery image. So sometimes, like, going through this process on a contract is kind of useful to try to see like what their system is for for storing metadata. Like if you want to see, is this particular contract storing stuff on IPFS? That's really kind of the main thing I'm always looking to answer is it using IPFS or not? Because the advantage of IPFS is you don't have to worry about servers going offline when the company gives up, or if the company or the guy who does it just gives up and moves on to some other thing. So always be on the lookout for IPFS stuff. But that's another useful function of the read contract is you can come in here, go to the token URI method, put in your token ID, and then you can have it generate the metadata URL for you. There's a few other ways to get it besides this, but this one I found is the easiest, fastest way that works for basically every project. Some other things you can usually try to find on the read contract is sometimes you'll see a max. You'll be able to figure out what the max supply is. So in this case, there's something called max dog adoption. Let's see. Oh, okay. So that actually looks like it's more of a limit to how many can be done in one transaction, I would guess is what that is. Max dogs might be what I'm looking for. Yeah. So here you can see max dogs. It's set the supply to 10,000. So usually, like, the most useful pieces of the read contract are usually like whether they have a max supply that's there, and then getting the token URI, and then looking to see what the total supply is, which is referring not to the 10,000, but to the fact that there's 8601 that have been minted so far out of the 10,000. So that's read contract. Write contract, you'll almost never, or I don't know if you'll ever actually try to call any of these. You probably can't without having the right address in the wallet, like you have to be the contract owner. But what I like to do on the right contract before I look at the code is this shows you all the functions that anybody, including the contract creators, can use on the contract. So it's always good to come in here and you can see like, okay, they have a single adopt function, they have a multiple adopt function, they have some housekeeping functions, they have some transfer functions and approve, which are part of the ERC 721 spec. So here's one that I usually look for is this set base URI. So this is an important function that a lot of contracts have that allows them to change that base URI that the metadata is stored at. So for instance, right now, they're storing the metadata on this server here, but it's that just, it points to an IPFS file that is that mystery function. In theory, they could change, just this folder to be like, instead of mystery to be like live or something, or they could change the whole server to be pointing at an IPFS server or something. So one way that people will change metadata is by calling that set base URI function. So this is a really important one to look at in the audit because you want to make sure that they set the permissions right on that function. And I'll show you whenever we get in there, because that's a really easy avenue for somebody to be able to really screw the project up. And you don't want to have invested a lot of money in a project with an error in a function like this. Another one that some projects do is they set a reveal time, which is nice. So this prevents stuff like what happened with, I think, the Bonsai project where people were able to buy early, or maybe it's the Cats project. I think it was Cats. People were able to buy before the actual launch time because they had accidentally had the contract turned on. So you can have some hooks in here that let you turn the contract on and off to prevent people from doing that. That way it's a fair drop. If, in this case, Kennel Club didn't really need it because it's only available to ape owners. But if it was a fresh project, then you want to be able to tightly control when the minting can occur and when it can't. And then this transfer functions, those are just boilerplate functions that are part of the spec. Okay, so those are kind of, this is a really useful tool for people who don't care about code at all. So if you're just a person who's like, I want to be able to like understand what's going on in a Nifty project, you can basically, keep watching the video, you might learn something, but this first couple minutes of the video will basically have everything you need to know to competently tell like what capabilities the project has as far as minting and max supplies and all that kind of stuff. Okay, let's dive into the code. And like I said, I've never before looked at the code on these contracts, so I'm definitely going to be fumbling a little bit, but you'll kind of see like what I'm looking out for. And I already kind of told you like the mint functions, max supply, how max supply is implemented, editing the base URI, and then any other weird stuff that might be going on here. Like sometimes the project owner will have special functions that they can use to mint for free. So I usually like to check those, make sure they're set with the right permissions and that kind of thing. Okay, let's go ahead and take a look at the code. So one of the reasons why I started with Bored Ape Kennel Club is because their documentation or their comments are usually pretty good. Their code's pretty good. So I suspect that this will be a pretty solid contract, and then it might go downhill a little bit from here. So let's see if they're doing anything crazy. So a lot of the stuff in here is going to be boilerplate, like interface definitions. You don't really need to worry too much about those. What we're looking for is the actual implementation. So you kind of just have to practice with programming for a little while to know what parts are meaningful and what parts aren't. But this is basically still mostly boilerplate stuff. And sometimes they'll have like library, like function definitions for just stuff, functionality they need in order for the contract to work. So that'll be kind of all mixed in here. So one nice thing about EtherScan is you can just collapse stuff. So get used to collapsing stuff. Okay, now we've gotten down to a slightly higher level contract definition. So I'm going to go a little bit slower here. This looks like it probably, this is probably the piece we're looking for now. You could see I had to go through about 500 lines of code to get to this. So constructor of the contract is usually kind of an interesting function to look out for, because oftentimes in the constructor, they'll do stuff like set the base URI. They'll do stuff like set the max supply. They might do some weird stuff. So I usually will always take a glance at the constructor. This one looks really basic, so nothing to worry about there. Let's see. So this is that token URI function that I was calling, and you can see that he's got a private function that retrieves the base URI, which might be worth looking at. And then he does like a quality control check on it, and then appends the token ID that you pass into the base URI right there. So I don't see anything particularly wrong with this. Okay, so base URI here. Okay, that's interesting. So this is a good example of something that's interesting. So this is basically this is placeholder. This is kind of what would be called kind of a template pattern. So basically, they define this function which doesn't have anything in there, and you would do that so that if you had a contract that extended this contract, you would be able to override this function with something meaningful here. So that's interesting. So you would always preserve the functionality here, but you might change the functionality here. So that's pretty interesting. Yeah, nothing else interesting here. I think this must be kind of still some library code that they just reused. Okay, here's a mint function. So we'll probably come back to, we want to see who's calling these guys. Interestingly, they have burn in here. Yeah, let's scroll down a little bit further. Okay, this is abstract, so that's not, again, this is not going to be the actual function either, because they're going to probably extend this. Okay. All right. Now this is finally the interesting piece. So what they've done, all of that code up above is probably shared code between the Bored Ape Yacht Club contracts and this Bored Ape Kennel Club contract. So that's kind of a good thing, because it means a lot of this contract code is already pretty hardened, which is nice. This is going to be all of the functionality that's specific to Kennel Club. So I've seen this quite a bit, although this is obviously they've been doing this for a while, so they have a pretty good pattern set up here. Some people will not have base classes that their contract extends. They will just have one object in here, one class defined. I think this contract is a little bit more complex just because they probably learned a lot from when they did Bored Ape Yacht Club, and they want to apply those lessons learned here. So this is probably a pretty good contract for newer people if you want to try to digest a contract. Definitely come and take a look at this one. Okay, so this is all the real important stuff to see now. So because this is so basically they set up some kind of like low level classes, and then they kind of build upon them and build upon them and build upon them. And now this is the actual contract that makes use of all that foundational code that they put together. So one of the interesting things and important things to see in a contract is these member variables that are declared. So this is basically kind of you can consider it the state of the contract that's going to be preserved in between operations. So stuff like max dogs, remember I had pointed that out on the write contract and the read contract, so you can, or at least on the read contract, so you can see that this is the variable that's holding that, and that is being returned when you query for it. And then of course base URI, which is important, and then those timestamps that we talked about. And sale is active also looks like an interesting thing to take note of. So here's the constructor. Like I said, usually constructor is an important thing to take a look at. You can see it looks like max dogs. Okay, so they passed in. So when this contract is initially created, they'll set some of the parameters. Sometimes, so one really important thing to look at, like as an example, is this is a member variable that holds state for the contract, and it's holding the max number of dogs, which we queried and determined was 10,000. If you set something in the constructor and you don't set it anywhere else, then you can have a pretty high confidence, because these contracts are immutable by definition on the Ethereum platform. So if this is the only place where this variable gets written, then it means you never have to worry about this project changing the total supply out from underneath you. So the easiest way to figure that out for sure is to just do a search. So I just do Control F. So places where it's just being compared to something, you don't need to worry about. What you're looking for is places where that value is getting set. So still just comparing. It's a comparison. It's another comparison. Okay, that's the original member variable, and that's where I started at. So, and I'll just go one click further, but then I'll go back. So basically, just now, like if you follow this process that I just did, then you can easily tell that this max dogs can't be edited. And so what that means is that this contract is 10,000 and that's it. It's programmatically guaranteed that max dogs is set in stone. I've seen quite a few projects actually where they have the ability to edit that number, because they'll have a function that lets them pass it in, one of those write methods that will let them pass in a new number for max dogs. So, or not max dogs, but for whatever they track their supply with. So this is a really important thing. If you want to really if you want to really have a guarantee that the number of tokens is not going to increase, then the best way to do that is to figure out how they keep track of their total number and then make sure it can't be edited. So you can, it's really easy to do like I just did. It would be possible for an advanced developer to figure out some ways to obscure rights to this. But nothing, I mean, if it's just comparisons like I saw, then you're pretty safe. But it's not outside the realm of possibility that someone figures something tricky out, but it would always still have to reference this variable. Okay, so we got the timestamps again. So this looks like basically, yeah, that's basically how they're controlling when this contract actually gets revealed. That's pretty cool. So I wonder if that one is right. Oh yeah, you can edit the reveal timestamp. So these are not controlling access to minting. They seem to be controlling access to the actual images. So they have that just set up in the constructor. And then they have a reference. So this is another cool thing I've been seeing lately is references to the, so this is a child contract. So it's references to its parent contract. So in this case, the parent contract is this BAYC variable that they're saving off. So that would be the reference to the parent contract. So anything where you see it interacting with BAYC, probably most likely what they're going to use it for is if you're trying to do in the minting function. So let's just track down where the minting function is real fast, and we'll see how they use that. Okay, so adopt dog. So minting function is, so if there's anybody who's watching, there's anybody who's watching this, it's really funny. These Bored Ape guys, they like to put these Easter eggs in the contract. So it looks like they haven't let me down. They put some good Easter eggs in here. So I'll probably be pinging them both later tonight. But anyway, so adopt dog, that it's the minting function. So really important function. Always want to check these because this is where you can see some weirdness, and this is where some bugs could really affect the value of the project. So let's see. So they're doing a couple of checks. Basically, make sure that I've mentioned that sale is active variable, so they can basically turn on and off the contract to if they don't want people to actually be able to mint. So that's a really good feature for newer people to smart contracts. If you're trying to do a project, you could come in here and look and see how they did the sale is active. Total supply. So you can see here they have a rule that says if the total supply is less than max dogs, make sure that that's true before you let the user continue. So this is basically where that max dogs is actually getting used to keep minting from happening if the supply, which we queried with the read contract, is greater than the total number of tokens that should exist. This just looks like them being a little bit careful. It's possible that something happened with the original contract where there was a token or tokens created above 10,000 or something like that. So this would prevent, looks like them just being careful developers. And this is that last piece that I wanted to point out. So I mentioned that they had that reference to the parent contract, the parent Bored Ape Yacht Club contract. This is a perfect example of how why they would need that, because they basically want to say you can only mint a new token from this contract if the address that is calling this method is a owner of a token from the parent contract. So that's basically what this function is enforcing. Then they're reusing that safe mint function that was in their library code. So I'm guessing the safe mint is a hardened function that a lot of people have tested and confirmed is a good way to mint stuff. So it looks like they're probably leveraging like past experience here. So that's really good sign. So this is a really basic minting function, nothing crazy or weird here. I see all the checks I care about. So I would say this is really solid. These adopt multiple dogs are always crazy because it's just more complicated because a lot more can go wrong if you're trying to mint 10, especially towards the end of the process. And they also have to make sure that your wallet has 10 or whatever number of dogs in it that you're trying to mint. So you can tell just by virtue of how many extra rules they have in here, and then they even have some extra logic in here. So they're doing the minting inside a for loop. So this is actually a place I'm not really going to try to wrap my head around this exact code in terms of looking for bugs right now, although I'll probably after this video come back and take a look at it. But this would be an example of like code that really needs to be scrutinized because there could be some really super tiny logic error in here that somebody could kind of exploit. And then instead of like being able to mint 2 like they should, they are able to mint 50, even though they really should have only been able to mint 2. So this is definitely, anytime you have a little bit more complicated code like this, it means it's not battle hardened. It means that there's possibility that it has some sort of logic error in there. So just keep an eye out for more complicated minting functions like this. This is a really good example of a basic single function, and these are much less likely to have problems. Almost always, anytime I see code that looks a little bit more scary, it's in these multiple minting functions. So just something to note for any contract you look at in the future, the errors are more likely going to be in the multiple mint functions. All right, let's see. The block stuff that they're doing, it's pretty mundane. I think they're just doing this as another like double check to make sure that people aren't minting before or after a certain point. And yeah, that's okay. We're at the bottom. So that's basically that's the Bored Ape Kennel Club contract. So, and the rest of this stuff is basically inputs that happened in order to get the contract set up. So if you wanted to see like what those constructor parameters were, you can scroll down and see it in this list. So I mentioned like, so they're passing in the name of the contract, the max supply, the timestamp of when they want the contract to start. And this is probably I'm guessing that's the original Bored Ape Yacht Club contract. So they're passing in the parent contract address. So that's probably the rest of this stuff here. This is the most useful piece, are these constructor arguments. All right, okay, let's see. So we're about 35 minutes in. I actually didn't expect this one would take quite so long. So I think probably what I'll do is call it here, and I'll still go over those other contracts that I mentioned and see if there's anything interesting. And if I find anything interesting, I'll make another video. Thanks for watching. Again, this is like just basically trying to get people a general level of comfort of understanding how the Nifty projects are controlled by these smart contracts, and what somebody who's just trying to get a little bit of a warm fuzzy should focus on in the contract code to know that somebody isn't trying to take advantage of you. So hopefully this helps you guys. Like I said, I'll post another video if I find anything interesting on the other contracts, but good luck, and always feel free to reach out to us at Nifty Culture if you have any questions. Talk to you guys later.